Hello and welcome to today's live stream. So today we'll be looking at Spring Boot features, and we'll be exploring it through a simple, quote-unquote simple application, backend application. The goal will be to build a few simple endpoints, and to do this with TDD, test-driven development. So that's what we're going to be looking at today. And before we start, maybe I need to set up today's poll. So let me just set up the poll. Today I'll want to know which Java backend framework do you use? So there's Spring Boot, Spring Framework, Spring Boot, and we have Quakers, and we have Jakarta EE. So what do you guys use? Leave your options on the poll and we'll check them out. I think that would be fun. So let's go ahead and start. So for us to do this live coding session, we'll start with the start spring.io. For those who don't know what Spring Boot is, Spring Boot is the #1 backend framework for building backend applications or server-side applications for Java or with Java. And it's a wrapper around the Spring Framework. So Spring Framework is the parent project for Spring Boot. So features that are available in Spring Framework are also available in Spring Boot, but Spring Boot adds additional convenience for Java developers in that some features that are available in Spring Boot might not necessarily be available in Spring Framework. And the main difference between Spring Framework and Spring Boot is Spring Boot works with convention over configuration philosophy. And that means when you're working with Spring Boot, you don't have to do a lot of configuration for your Java backend solutions. Instead, most of the things come pre-configured out of the box. So you don't have to do the configuration on your own. And that's super convenient, especially if you want to build and ship quickly and not worry about extra configuration like the application container, say, configuring that. In fact, Spring Boot comes with an inbuilt Tomcat container, which means you can package your application in one jar file and run it on a server, and it will be all good. You won't have any problems. So that's what makes Spring Boot special. Spring Framework is, if you want to be more surgical about your implementation and perhaps you want to do a lot of configuration, Spring Framework would be the thing you'd go for. There's also Quakers, which I haven't explored. I think in another stream we'll check it out. But the other solution is Jakarta EE, which is the parent project for Spring Framework itself. And it's mainly comprised of specifications like JPA, JAX-RS, and other specifications in the standard. So Jakarta defines the specifications, and then you have reference implementations, and then Spring Framework, Spring Boot, Quakers, and the others form wrappers around the implementations of those specifications, which makes it more convenient and easier to work with for the Java developers. So it's a very thriving community of backend tools and backend frameworks, which makes really development really convenient and perhaps I should say easy. Though there's nothing easy about it, there's still a lot of stuff you need to know about. So today we'll be attempting to build a simple backend application, and this backend application will be a movies application. It will have one entity because the purpose of this is to demonstrate how you can build a backend Spring Boot application end to end with test-driven development. So that's what I'll be attempting to do in the next hour. If you have any questions, leave them on the chat. I'll check them out. And let me know which Java framework, backend framework you use for your development on the poll. Awesome. And if you have any questions, just shoot them to me, and I'll be more than happy to answer. So right now I'm in start.spring.io, and in start.spring.io, I don't think you now need to see me as much. Perhaps I could just shrink my window a bit. Okay. So we are going to start in start.spring.io, and here in start.spring.io is where you're able to quickly initialize an application. And the great thing with this tool is it allows you to do the initial configuration for your backend Java application. And the main thing is at the end of it, you either get pre-configured Gradle build scripts or Maven build scripts, the pom.xml and the rest. So that's very convenient. So I'll select what I usually work with. So I prefer Maven over Gradle. I also prefer Java over these two. But Kotlin is becoming very popular. However, I prefer Java. The Spring Boot version, this will be an experimental stream. I think we can use 4.1. 4.11 will be too experimental, so 4.1. And the package name, I'll use some programmers, and the application will be movies. Perhaps we should give it a more interesting name. Films backend maybe. And packaging option, you can choose WAR file or jar file here. The main difference is with the jar file, it's click and run. So you don't have to do anything extra after building or packaging your application. WAR files are built for standalone Tomcat instances. So if you're not aware, Tomcat is the preferred application container for Java developers. And this is the website where you can get Tomcat. So in the Java backend development architecture, you have something called a servlet, and you have a servlet engine or a servlet container. Some people refer to it as application container. So servlets are what enable Java applications to communicate over the web. Essentially, the main thing is servlets allow you to implement the HTTP spec within Java. That is the hypertext transfer protocol for client-server communications. So servlets enable you to implement that. And once you implement the HTTP specification, the Java code that results from it, you can throw it inside a servlet engine. An example of a servlet engine is Apache Tomcat. And the servlet engine will handle the work of routing requests to the specific parts of your code. So if somebody requests for a web page like get index.html, the servlet container will be the first one to pick it. Once the servlet container receives that request, it will determine which part of your backend Java code should be invoked for that request to be accomplished. So that's the importance of Tomcat. And even when you don't interact with Tomcat directly, you still interact with it indirectly. For instance, within Spring Boot, like I mentioned earlier, Spring Boot does internal packaging for an inbuilt embedded Tomcat container. So whether you are setting up a Tomcat instance separately or you are just running your Spring Boot application, Tomcat is always involved. Very few and fewer people do a standalone setups for Tomcat, so it's a rare thing, but some people still prefer to do that. I know in my own setups, I prefer to have Tomcat set up standalone because it allows me to do some custom configuration like supporting HTTP2 and stuff like that. So, and also it allows you to have a very custom backend. So you can do a lot of interesting things if you are able to set it up and configure it and manage it separately from your Java code. Great. So at least we know that. And when it comes to configuration, I prefer application properties because YAML is a bit like Python in that you get indentation errors, and application properties or properties files are more simple. They are like Java maps. It's key value pairs, so it's difficult to confuse key value pairs. But if you have a more advanced configuration, maybe you're working with Docker, you're working with something like Kubernetes, you might prefer YAML because your configuration will be a bit more complex. But if your runtime is more bare bones, old school, where you have a separate Tomcat container, you have a separate database, you have a separate runtime environment, application properties would probably be the tool to go to. But if you are doing like microservices and want something more modern, definitely YAML will be the thing to go for here. I'm currently running Java 25 locally, so I would choose 26, but I'll still go with 25 because just to avoid any surprises. But 26 is available. And with what we will be doing, there won't be much of a difference between what we get from 26 and 25, maybe runtime performance. If the garbage collector is a bit more optimized, you probably see a bit of a difference there. So now we can add the dependencies. So for this, we'll be doing a web application. So the first thing to bring in is web, and this will bring in mock web MVC, of course, not mock MVC. This will bring in web MVC. It might also bring in web MVC, which is a Spring Web Test. Yeah, I think that will be brought in automatically. And a web MVC is the Spring Framework's way of wrapping the servlet architecture that I talked about earlier. So if you are writing plain servlets, you'll probably have to prepare to interact with the servlet container directly or servlet engine directly. Spring MVC adds convenience methods and additional pre-configuration that allows that process to be much easier for you. So you don't have to implement HTTP servlet directly or do any of that stuff. You can just have regular Java classes working as controllers. So you see it uses Apache Tomcat as the default embedded container. So instead of having a standalone Tomcat, you get to have this Tomcat container embedded. So it doesn't have to be standalone. But if you choose to, it will still work standalone, like a selected WAR file. So if I want a standalone package to drop in a separate Tomcat container, I'll still be able to get that. If we didn't have records, I'll probably use Lombok, but there's some issues with JPA and records. So just to be safe, I'll bring in Lombok along for the journey. HTTP client is important if you're communicating with an external service. Maybe you're building a microservice environment and you have one server that communicates with a different, one service that communicates with a different service. HTTP client can be very useful. There's also a Spring template, REST template, yeah, there it is, which comes with this package, it seems. So that is our web layer. Persistence is important. So we'll need to bring in Spring Data JPA. So Spring Data JPA wraps around Hibernate, and Hibernate implements the Jakarta EE-JPA specification. So we'll bring that along for persistence. I think we need a driver. I'll be using MySQL for persistence, so I'll need a MySQL driver for that. And I think we are good. I don't think there's anyone else we need to bring in. We might bring in ThemeLeaf if we want to do a UI, but this will be REST based. But if we get the opportunity, perhaps we might check out ThemeLeaf. So I'll bring along ThemeLeaf. And if you forget to add anything, you don't have to worry because you can always add the dependencies directly to your POM file. And this is the POM file that you will get. It has the artifact, packaging strategy. This is rare for people to choose WAR file, but it's just my preference. I prefer WAR file. Of course, Java 25, ThemeLeaf, Spring.jpa, WebMVC. This brings in the connector, which is runtime, of course, Lombok, and we get the embedded Tomcat. Then we get the test dependencies. So this is what I was looking at. So we get WebMVC test, we get ThemeLeaf test, we get data.jpa test. So we are good that far. So that should be it. Let me just check if there's any answers to the poll. Okay, I'll be checking the poll, and also if you have any questions, you can leave them on the chat. So if I'm satisfied with this, you can just go ahead and download it. So I'll go ahead and download. Okay, so it's downloaded. Let me just so what usually happens is it downloads a zip file, and you can unpackage that zip file and open it in IntelliJ. So what I'm doing is I'm unpacking that zip file, and once I've unpacked it, I'll be able to open it in IntelliJ and start using it. Okay, let's go to IntelliJ. So I'll open the file. It should be in desktop. Fields backend, there it is. And I'll select the pom.xml. Then you can select open as project, trust project, and that should open it. Yeah. So here in IntelliJ, we have the file. If we open pom.xml, you'll see we have the stuff that we had configured. Spring.jpa, we have ThemeLeaf, we have WebMVC, and we have the project definition. So I'll call this, you can change the version to 1.0. But otherwise, we have all the dependencies we need. So just to be sure, I'll build this. So it will build, and if there are any issues, I'll be able to see. So there are some test failures. And of course, we haven't done any configuration for the test, so that's understandable. And what we can do is in fact, you can get rid of this default test. and try and build again. Okay, so that's successful. So once we've built it, now we can exit and we can begin writing the application. So what we want is a simple backend application. Our backend application will have one model, which is a movie. It will just be storing movie. I won't be adding other entities. Let me just have a README here for planning. So we have our movie API. That's what we'll be building. And our movie API has our entity is movie, and the fields is ID, the name of the movie, the director, the name, the director. No, in fact, let's do release date instead. So I'll keep things super simple for this, just to, because the idea is to demonstrate these capabilities. We won't have Spring Security. That will be for another occasion. Instead, I will just have the persistence layer. So we'll need to build persistence. So let me label this as work. So we need persistence. Could use an emoji to mark progress. So we need persistence. We need a service layer. Remember, we are building with the web MVC, model view controller pattern. So with that model view controller pattern, our model layer will have a service layer. Then we'll need to have, of course, our endpoints, which is our REST endpoints. And that this will be our view layer in the MVC pattern. I think this should be it. So let's start. So first, I'm going to create we probably don't need a package for this, so we can just go ahead and create the movie, and it will be a class. It would be nice if it was a record, but for now we'll make it a class. So what makes this an entity is the entity annotation. So that will make it discoverable by Spring. So what happens is there's this idea of component scanning. So any of your classes that you annotate with any of these stereotype annotations like entity, there is other annotations like at service, there is at repository, you have at controller, there's even a more specialized one like REST controller. So these annotations will be discovered by Spring, specifically a part of Spring called Spring IOC, the inversion of control container. And it has a factory bin. It has like a box in which it stores ready to go instances of any of the classes that contain these annotations. So if they are needed anywhere, if your service layer needs an entity, if your repository layer needs the service layer, if the service layer is required by the controller, instead of creating a new instance of the object that's required, Spring will do dependency injection, which means it will inject an existing instance of the classes. And to do this, it uses something called a singleton pattern. So it will create a singleton. Let me get the spelling for that. So it uses the singleton pattern. Singleton. And the singleton pattern just refers to, there's a whiskey brand called Singleton. That's new to me. So the single role pattern means a single instance is created within your program, and that instance can be used in multiple parts of your application without having to create new instances. So you save on memory, you save on complexity, and it makes your program more efficient. So in object-oriented, the single role pattern is a software design pattern that restricts the instantiation of a class to a singular instance. It is one of the well-known, so you can get this from Gang of Four design patterns, which describes how to solve recurring problems in OOP. The pattern is useful when exactly one object is there to coordinate actions across a system. So when I create a movie and I mark it with entity, there'll be only one instance during the runtime of the application. So if any part of the application requires an instance of movie, it will try and find an existing instance, at least within that. It might not apply to the entity per se, but I am just using it as an example. So if I have a class and I annotate it with the repository, there'll be only one instance of that repository available for anybody that wants to use it. Yeah. If you want to read more about it, look for IOC container. There's a lot of literature on that. So you can find that on the official documentation. I'd encourage you to read it. And this describes the IOC container in depth, shows what you can do with what Spring provides in terms of this bin factory. Like I said, you can imagine the bin factory as a box, and inside that box, you can have instances of your repositories, your services, your controllers, all stored there. So when any part of your program requires a copy of or an instance of those classes, instead of creating a new repository or a new controller, Spring will go into that bin factory and pull an existing instance. So check this out. This goes into a lot of details on how to do this. And this is Spring Framework, so the configuration is XML. But just read it for the theoretical understanding of what goes on. And it's still relevant because, like I said, a Spring Boot just forms a wrapper around stuff like this additional configuration for the IOC container. So we'll create our entity. We'll create all of these later on, so don't worry. You won't be missing out. So from our specification, our entity has an ID. So the ID will be simple. We'll use a long for the ID. And I usually prefer to use long so that if I want to change the tests a little bit, I can do that. And I'll demonstrate why using that might be useful. So I'm going to create the entity, but I've noticed I've broken the first rule of TDD, which is we should not write any production code before we write a test. So I'm actually breaking some rule here. So I would encourage you to visit, there's this Uncle Bob article on TDD. It's very popular, the cycles of clean code. And in this, Robert Martins goes into a lot of details into how to do TDD, but most importantly introduces these three rules, the rules of test-driven development. And rule number one is, okay, I lost it. Rule number one is, so create a unit test that fails, write production code that makes that test pass, and then clean up the mess you just made. I noticed he has simplified these rules. Yeah, but the main point is you don't write any production code before you've written a test that fails. So we're going to start by writing a test that fails. And the way we do that is, in fact, I was the test directory. This is the test folder, this is the main. So this is where we were supposed to declare this movie, in fact. So I'm going to rename that into movie persistence persistence test. And this is how we are going to test the persistence of the movie object. Persistence. So this won't be an entity. Instead, it will be a test. And the way we mark it is we'll say this is a data JPA test. So this is the annotation that we use to annotate persistence layer tests within Spring. Then I'll be using JUnit, but I need JUnit to be aware of Spring. So to do that, we'll need to use this annotation called extends with. And it extends with Spring extension.class, Spring extension. So what happens here is using extends with tells Spring that this test will require, it basically tells JUnit that this test will require a Spring application context, and the Spring extension will handle bringing that Spring application context, or at least making it available for the test. Then we'll have a simple test function here, and this will be should persist movie test. So this test will ensure that the movie is actually stored in the database, whichever database format we are using, as long as the other components are not broken. So of course I'll annotate it with the test notation, and this is from JUnit, JUnit 5. That's why it has that Jupyter in the package structure. And to make this test successful, I'll need to bring in a few things and be using something related to the IOC concept that I talked about. This is that auto-wired annotation. So auto-wired annotation does dependency injection. It injects a singleton instance of the object I need. And the object I need for this is a test entity manager. So this test entity manager handles the, so if you look at the Spring Data JPA specification, you'll notice there's this concept of an entity manager. So this will bring in a entity manager specifically designed for running integration tests, or you might also call them unit tests. So alternative to entity manager for using JPA tests provides a subset of entity manager methods that are useful for test, as well as helper functions for common test tasks such as persistent flash. So when you're running a test, the data that you store should not have a long lifespan. In fact, if you are persisting any objects in the database, they will live only as long as that test function is active. So once you exit the test function, if you exit this, the object should be removed from the database. So test entity manager gives you functions to allow you to do that. One of them is flash. So flash will clear everything that you've stored in the database, so that when you're running the next test function, you're sort of starting afresh. So that becomes very helpful. And it allows you not to have to set up your own before and after cleanup functions. Normally what you would do with the regular test is you'd have this before each annotation, and have a function there like setup. And setup will, for instance, initialize init the DB, and then at the end of all the tests, every test function will have after each, and after each allows you to do cleanup. So cleanup. So here you might decide to delete everything from the database and start afresh. At least start afresh in terms of when the next function begins, let it start with a clean database. But with the test entity manager, we don't have to do this extra work. So essentially, that's what it saves us from. Okay, so for this to work, we'll do maybe three things. First, we'll create an instance of movie. Then the second thing we'll do here is we will persist the movie. Then we will check if movie is persisted. So we'll check whether it's stored, and then we will end this function. So it's just 3 things we need to do. So I'll go ahead and make a movie. So maybe this movie can have an actual name like Tenet movie, and it will be an instance of movie. And we know that movie has 3 properties. It has ID, which is a long, so I'll use 1L. It has a name. In this case, the name of the movie is Tenet. Then it has a release date. I can't remember when Tenet was released, but I'm just going ahead and to guess. So we'll say it's maybe 2021. I think it was around that time. And we can guess the rest of the values for this. So that will be the release date, that will be the ID and the name. So ID, name, and release date. So those should be the values. So once we have this Tenet movie, which we can see we already have errors here, following the rules of TTD, once we see that our test is failing, because if we try to execute this test, of course, we'll get a failure. So once we see that our test is failing, the next thing we will do is we are going to write production code. So now we are permitted to write production code. So we must write a failing test before you write any production code. That's rule number 1. The rule number 2 is you must not write more of a test than is sufficient to fail. So once it fails, don't go ahead writing the test. And also you should not write more production code than is sufficient to make the failing test pass. So those are the rules. So we are going to go ahead and create our movie. Since we don't have one, we need to create a movie entity. Call this movie. It's just a regular class, and we should not do anything extra here. Just enough to make this work. Of course, it has some fields. We have an ID here that's long ID. It has a name, which is string name, and we have the release date, which is local date, release date. There we go. So we have the fields, but we need that constructor. So we'll go ahead and employ Lombok services here. So I'll bring an all-args constructor from Lombok. I'm preventing myself from writing any additional code than we need for the test. So now if we run the test, enable notation processing, you see we still have a test failure. Let's see what's causing the test failure. So the cause of the failure is data source. So we haven't configured the data source for persistence. So when we try to initialize Spring Data JPA, we'll get a problem. So what we need to do is we need to have the data source configured in application.properties before we can move ahead. So I'm going to go to, so you can have 2 actually. So within your test, you can have a resource folder, directory resources, and here you can have your application properties for testing, application.properties. So this will be for your tests, and for the production code, you can create a file right under resources, call it application.properties. properties. Okay, so it's seeing that we already have this here. So we could rename it to something else, though I was expecting it would allow us to have that. So we can call that test.application.properties. And here we can have the main application.properties. Oh, okay, it actually already exists. So when we're initializing Spring, when we went to start.spring.io, which I already closed. So when you go to start.spring.io, when we initialize the project here, it already added an application.properties file for us, which has the application name. So we don't have to do that extra work. So now we need to configure the data source. So I think the key is spring.data source. And here we'll just tell it which, we'll just point it to MySQL. Let me just see if I can find a preset config for that. Spring data source key. So the key we are looking for is spring.data source. Yeah, so spring.data source, I think we don't need the data prefix. Just need to specify the URL, and this will be MySQL. We start with JDBC and MySQL, localhost 3306. And the database name, let's say we're working with a films database. I think that should do it. Let me just make sure. So yeah, so data source.url. So this one is h2. Oh yeah, we need to specify the username and maybe the password for that data source. Since we are using MySQL, that will be, so I just have a default setup of MySQL. So this will be root and spring.datasource.password, and this will be empty. I think that should do it. We don't need to set up cache connection pooling, JDBC, MySQL, localhost test. Yeah, that should be it. Wait, I don't even need to specify the port number. Okay, I didn't know that. So we have the username, we have the password. I'll skip connection pooling. This is just a demo application. We don't need to take it that far. So let's see if our test is able to execute. So now you see the importance of TTT. It allows you to catch even some of the some components that you might not necessarily pick up on, at least on the start. Because I was expecting that the data source will be preset, will be configured. So that's interesting. Okay, so you see that the test is still failing. So let's see what is the reason for the failure this time. So found required class javax.sql data source. Embedded, oh yeah. So there's something we forgot to do. Since we are writing integration tests for our application, we need an in-memory database to serve as our target for database level tests. And for that, there's an in-memory database that we use. It's called H2. H2 in-memory database. So we need H2, and H2 allows you to have an in-memory DB. You can also do this with SQLite. SQLite also supports in-memory persistence, but Spring has H2 support out of the box, so you don't have to do additional configuration to work with H2. So that will help us with that, so that it doesn't become something that we need to worry about. So the way we bring in H2 is we're supposed to bring it on the onset. We're setting up the application inside to spring.io, but we can still bring it in later. We just need to see which part of the POM file we'll need to edit. So the bit we don't have is this part, which brings in the H2 dependency. So I'll just copy that and I'll bring it into our POM file. So just on the dependencies, I'll just add it at a good spot. Like since we're using it for tests, perhaps this would be a good spot to add it. So this brings in H2, and as long as we have it there, we should be good. Let me run my event clean install once more, just to make sure that we have the package. So Maven will be responsible for pulling the actual package into our project. So that's what's great about Maven. And now, since we have H2, I don't think I'll need to do additional configuration for this. Let me see how we do. Nice. So H2 has handled the data source issue that we were having, but it also forced us to set up the production level persistence. So at least now we know we have a persistence for the production application with the MySQL, but when it comes to the test, we don't need to provide anything here because H2 is handling it. So H2 handles test level persistence. So our test is passing, which means we can go ahead and write some more production code, a test code. So when your tests are passing, you write more test code so that you have a failing test, and that would give you the license to write your next unit test. So let's go ahead and add the next phase. So we've created an instance of movie. The next thing we are doing is we're going to persist the movie. So to persist it, we're going to use the test entity manager. So I'll call test entity manager, and I'll call, so this persist. So this just saves the object into the database, and you can run additional testing after. There's persistent flash, which persists the object, gets that instance of the entity, whichever value was in that database table row, and once it returns that value, it clears the database. So this is usually the most preferred, especially if you're just testing persistence, because once it's called, you'll get back a valid instance of an entity. If nothing was saved, you won't get back anything. So that's what makes it special. So make an instance managed and persisted, then synchronize the persistence context to the underlying database. So delegates to entity manager, persist, then it calls flash, and finally returns the original source entity. So this is really nice. So it actually does the actual save on the database, but it returns the actual value on the row, and once that value has been returned, it clears the database. So you don't have to do that cleanup work on your own. So that's super nice, I think. So I'll just go back to the test here. And to call it, we'll just pass in the entity you want to persist. In this case, it's the Tenet movie. And like we said, once it's done, it should give us an entity. So once we have an entity, now we can start doing some comparisons here, or verifications. And to do verifications, I prefer to use this library called AssertJ. AssertJ it's not very different from default assertions that come with JUnit. But I like the syntax. I prefer the syntax of JUnit. It feels more flexible. So you get this assert that, and you can pass in what you want to assert, and you can use different versions on the other side of this. So you can do equal to, you can do not null, you can do is empty, and also it's type sensitive. So if you're checking like a double, you can check for size is greater than, is less than. Just makes it really nice. And also there's additional chaining that you can do with it, which is really, really good. So we're going to use assert j. So I'm going to import that assertion. So I'll do a static import, assert j. Let me import the specific function, assert that, assert j. Okay, it's not doing it automatically. I was hoping the ID would help me with this. Let's see. Okay, so we are going to org.assertj core, then so there's API, there's condition. So one advantage of doing these imports on your own, it allows you to explore the API also, so that your knowledge of the API is not limited to only the functions that you use. So assertions, I think this is where we'll find assert that. Okay, so this is what we are using. So assert that entity, our entity is not null. So once it's pulled from H2, it's not null. We can also check that our entity has the properties we expect. So for instance, the name, entity dot, oh yeah, so get, we need a get name here to check the name. Is not, maybe it's not empty. But you see, we don't have get name. So if we try to run our test, it will fail. So now we have license to go to the production code and start messing around with it. So what we need is getters and setters. So I'll use Lombok, which will give us getters, and also have it give us setters, so that we can proceed. So get, that will handle get name, and we check that get is not empty, the name is not empty, and we can now check the next property, like the release date, and since this is an object, we can check that it's not null, and we can also assert that entity dot id, get id, which is long. First of all, is not null, and we can also match the actual values for these properties, like entity dot get name. We can ensure that that name is tenet, so dot is equal to name, referring to this variable. And we can also check the release date, assert that entity dot get release date dot is equal to. So here we can utilize some function that's available in local date that gets the temporal value for the date and checks it against another temporal value. So we can call release date, which is the value we used for persistence. And here we can check, check that this is true, that they are actually equal. So get release date is equal to that, should give us true. Then we can check the ID for fun, set that entity. I'm saying for fun because some interesting things might happen with the ID, but we'll be able to explore that. Is equal to ID. Okay, so we have a good test here. Let's run it. Okay, so our test fails as expected. So movie is not annotated with entity. So we need to have the entity annotation on the movie to make it an actual entity. Otherwise, test entity manager will not persist it. Back to the component scanning issue that I mentioned earlier. When component scanning is done and this annotation is not present on this class, Spring will skip it and it will be added to as a bin to the application context, which means Hibernate will not discover it, which means JPA will not, it will not be used as a JP entity. So it's important to have that. Otherwise, of course, the application will not function if you don't have that. So just looking at our checklist, we created the movie, we've persisted the movie, we've checked if movie is persisted, we've checked if the movie is persisted, and that should be it. So now if this test passes, we are good with persistence. So now let's move on to other things, which is getting the test to actually work. So I've added the test entity annotation to it. So I just want to see if that fixes everything for us now. Okay, so that doesn't fix everything. Instead, let me just make sure we know exactly why the test is failing. So no named parameter. It's always good to read these error messages so that you also understand, because I have a guess as to what went wrong, but it's also good to see how Spring reacts when you miss something. So it's very long. Let me see if I can get something more specific. Unconditional class, exclusion none. So transaction auto-configure did not match. Did not find required class. Okay, something to do with Tomcat, but we are testing persistence, so that should not be an issue we should worry about at this time. Instead, let me just kill this for a bit so that I have more space. So instead, okay, so transaction manager, okay, that brings us to something we are familiar with. Did not find any beans. Okay, JDBC template. Okay, again, still referring to data source. And so it looks like we didn't set up our movie entity correctly. And I can already guess that the thing that's causing problems is the lack of primary key. So let me attempt to do that. So we'll have a primary key by adding the @id annotation. That's from Jakarta Persistence. And that @id annotation, we can have this ID be generated. So that it's auto-generated, and we can give Spring Boot a strategy for generating it. I'll use identity for it, generation type identity. And let's see if that solves our problem. Okay, so test is still failing. Detached entity passed to persist. So yeah, so this is why I said things would get a bit interesting. So when you see this detached entity passed to persist, it refers to a conflict. You have a stale object. So you have an object that it's within the transaction, but it seems like the object was not properly persisted. And also we are trying to reference properties that are inside that object. And the way you deal with that within Spring Data JPA test is you set the initial ID to null, so that when the ID is generated here, you won't have a conflict. Because JPA is trying to generate the ID, but also we are passing the ID ourselves. So that causes that detached entity error. that you saw there. So detached entity persists, pass to persist. So whenever you see this, just remember whenever you have a generated ID and you're trying to use it in a test, Spring Data JPA won't be happy with that. So it's good to pass in null at least at the onset. And it's just limited to the test alone. So when we do that, it means, of course, the ID will be a correct ID and it won't be null because we are trying to check whether the ID is null. So in real sense, we won't know what the ID will be because it's being generated. So it's good to not check the ID for an actual value. You can just check that it's not null. And now if we run our test, we'll see that we are good. The test passes. So we're able to persist movie. So going back to our checklist of things we are supposed to do, persistence is done. So persistence is not an issue that we are working on. So we've managed to get that, but there's a problem because persistence is multi-layered. So we have the entity layer, and we have a repository. We need a repository so that the service layer will not be creating its own entity manager and trying to do database transactions directly. Instead, it can use the repository pattern, which is way more convenient. So we've finished this. We've finished that, but we haven't finished this. So this is still pending. So what we're going to do is we're going to work on the repository layer and get that done, hopefully. And the way we do that, of course, we need to begin with a test. So I'll create a test. I'll call it movie repository test. And this movie repository test, just like the other test, will be a data JPA test because it's testing the persistence layer. The advantage of using this specific annotation, it limits the test to persistence. It limits the test to Spring Data JPA. So it doesn't try to load your services. It doesn't try to load your controllers. It will only load your entities and your repositories. So that's why this is super important to use. So, and when you do that, your tests execute faster than they normally would. And of course, I'll try to let JUnit know about the nature of our test, that letting it know that we're using a Spring application context, which will have the factory bin and will need the dependency injection and all that. So this is just a communication to JUnit. You can see the annotation is from JUnit, and we are passing this Spring extension to it. So for this test to work, we'll just do a simple maybe we can do two simple JPA repository layer operations, which is to save and to retrieve. So here we'll test that we should be able to save a movie test. And so that will be the first test. The second test we'll do is we should be able to retrieve. That will be our second test. And maybe we can do the CRUD cycle and do should delete movie test. And this will test our ability to delete the movie. So let's go ahead and handle the saving part. So I'll bring in, just like in the other case, we'll need to auto-wire the repository that we still haven't created. So movie repository, since we are not using test entity manager here, we'll have to have the actual repository so that we can use it for this test. So I'll just mark this with the test annotation, and it will be the first test that we do. If I run it, of course, it will fail because we don't have a repository. So I'll go to production code now. I have license to go to production code, and I'll create the movie repository. And we'll need the stereotype annotation repository. In some cases, you don't need it, especially when you extend JPA repository, but let's do a case where none of that is done yet. Again, following the rules of TDD. So we just have the movie repository. And let's run our test and see if that fixes things. Okay, so we still have a problem. And the problem, I believe, is unsatisfied dependency. So error creating movie repository test. The unsatisfied dependency is repository. So this, because component scanning wasn't successful and the movie repository doesn't qualify as a bin, therefore, for this to work, we need to annotate it with repository. So that will make it discoverable by Spring, and we will not get that error again. I think might be wrong. So unsatisfied dependency, error creating a bin with the name movie repository. Unsatisfied dependency expects through field repository, not qualifying bin of available. Expected one auto-wire candidate. So that should have fixed it for us. Because if you mark it with the repository. Oh yeah, so the other thing with the Spring.jpa repositories is their interfaces. So let's see if that is what we are missing. No. That should have worked. Satisfied dependency. Oh, okay. Field repository, no qualifying bin of that type. So that should have fixed it for us. So we'll take it a step further. So do this until the test passes. And we'll say this extends JPA repository. And with JPA repository, you can pass two things. You'll configure the type of entity, and you'll configure the type of ID. This just tells Spring.jpa the types, not necessarily the values. So the entity here is movie, and the type of our ID is long. So again, this is why it's perhaps important to use object type for long, because generics doesn't support primitive types, but also perhaps probably JPA has some way of addressing that boxing issue, so that if you are the ID of your entity is a primitive type, it will be able to map it to an object type without you having to change the signature of your entity. So that might not be such a big problem. So I'll run our test again. Okay, so looks like it wanted us to extend JPA repository. So you make it an interface, and then you extend JPA repository, you pass in the entity and the ID type, and you're good. So then we'll do the next step, which is to use the repository to persist. So first, let's do some planning. So the first thing we'll do is, of course, create a movie instance. Then we will persist that movie, this time using the repository instead of the test entity manager. And then we will validate the movie that we get. So I'll create a movie. It's equals to new movie. And the properties of the movie, of course, the ID, the name. This one is pressure, just came out. And release date, let me make this separate. Release, which is the release date. I will use local date, of course, of maybe So it's 2026, and probably came out in February, somewhere the beginning of February. And yeah, that's the release date. So let's make sure that we can do that. So I'll just run the test. Okay, the test passes. This is pressure. Then we'll use the repository to save. So the good thing with the repository comes with these inbuilt functions, save, retrieve, all of that. So we'll save the movie. And when you call save, it returns back the persistent object, just like persistent flash, except it doesn't do the flash bit. Saves a given entity, use the returned instance for further operations, as the save operation might have changed the entity instance completely. So to return the entity to save must not be null. Or you pass in the entity, which must not be null, and then returns the saved entity. Yeah. So now we can go back, and so this will give us the entity that we saved, our entity, and we can do some assertions on it. We can assert that the entity that's returned is not null. Of course, that means we again need to import assert_j. This time I'll use this shorthand to try and get it in quicker. Assert that. And we can assert that it's not null. Just like the other case, we can check some of the properties, like the name. We can check that it's equal to the name we are using here, which is pressure. We can assert that the entity release date is the same as the one we used. And we might also check the ID. So we might get some surprises when it comes to the ID. So I'll just check that it's equal to 1L, which is 1 long. Okay, so our test is failing, and let's see why it's failing. Object optimistic locking failure. Row was already updated or deleted by another transaction for entity. Yeah, so this could still be related to the ID thing. So let's change it to null so that we allow Spring to set up its own ID. And since it's null, I don't know what Spring will generate for the ID, so I won't have an assertion for the value of the ID. We can just check if the ID is not null. So although I've seen the test as passed, let me just add this so that we don't completely neglect the ID. At least we check that it's not null. Java being type safe, I won't need to check that it's long, so that's nice. So yeah, so that passes. So we know our repository, at least the save function of our repository works. So we can test other functions. So to test retrieval, we'll need to save a movie first. So I'll reuse some of the code we have here. And yeah, just check that it's not null. What did I do? Okay. So so for this test, at least the setup phase will be to persist that movie. And the function we are testing is this retrieval. So let me call this movie from, what will we do? Yeah. Because we're able to get the entity once save happens, but we want to make sure that we get the same entity when we call retrieve from the repository itself. So let me call this saved entity, and we'll call repository dot find. So there's multiple find functions. We'll use find by ID. Yeah. And we can use whichever ID has been set up for this entity. Since we passed in null, we know there will be an ID value. To be sure of that, we can actually log that ID. I think Lombok comes with some inbuilt annotations for logging. So yeah, so you can use that. So it will look for a logger in the class path and utilize it, either log4j or one of those. Does the automatic setup for you, so that's kind of nice. So you can do log, I think it's just log, yeah. Or if you just call log and pass it a string. Maybe it's, yeah, it's log dot log, and yeah, I think just pass in the text. Do you need to pass in any other? But let me just check the signature for this. Yeah, just receives the topic, which is default. So yeah, I want to log the entity ID. Entity.id. Method call expected. Okay. Looks like I've forgotten how to use as a Lombok's a log function. I'll just check that. So, oh yeah, okay. You pass in, you use the level of logging. So you can do log.info, but it's conflicting with something here. It's conflicting with something in my class path, because this should work. I'll pass in the log message. That should have been okay. Okay. So it's log.info. Okay. Yeah, otherwise I'm referring to the annotation directly. Okay, so we want to log the entity ID. And as I think I might have forgotten the signature here. I think you use something like that. Okay, we could also just concat it, but I think there's some fancy way of referencing the attributes so that you don't have to concat. But anyway, that's not the main event. So we get the entity ID. So I'm just logging that just to make sure we got an entity ID generated here. And now we can do some assertions on the saved entity. Save entity. We can check that it's not null. We can also check the save entity for some properties like the name. Oh yeah, another thing is find ID returns an optional. So since it's optional, we might need to unwrap it first. So we get an optional save entity. So if optional dot is present, then the rest of our code can proceed. There could be a better way to write this, but just use that. So if present, then we'll have our save entity, and we'll retrieve it from the optional by calling get. And once we have it, we can check for some properties. You can check the name is equal to pressure, and we can check the release date, and we can check that it's equal to the release date that we used. And, let's see. So it's true. So those should be the same. So to validate this optional, we can add an additional assertion here for optional.isPresent. So this will check the optional and ensure that there's actually a value. And the ID is also detected that, which the suggestion here is we might not need to have the if statement. Since our assertion will have already checked, we can do a dangerous get. So what get does is, if the optional is empty, it will return null. But since we've already validated that it has a value, if this assertion works, then we don't expect this to be null in line 34. I forgot to annotate this with @test. So now it's annotated. Yeah, and we see that that works. So since I've seen JPA is working, I don't need to test those internal methods any further. So if we go back to our task list, we'll see that now the repository is working. So now we can go to the service layer. And in the service layer, we'll just do some simple CRUD operation. And of course, I can't create production level code. So we'll start with the test first. And I'll create a movie test. This is movie service test. And the movie service test, of course, now it won't be a data JPA test. And it won't be, so there's no equivalent annotation for service layer tests, because these service layer tests are supposed to act as intermediaries. They're not supposed to be too embedded with either the persistence layer or the controller. In fact, in most of the cases where I write service layer tests, I don't use Spring Boot level annotations. I try to test those functions as you would test regular Java classes, like plain old Java objects. So I will only be using JUnit here. So I think for that, do I need to even mark it with anything? So the only thing I'll be using here mainly that's different is Mockito. So I think I can bring in Mockito extension. So instead of bringing in Spring, I'll bring in Mockito. And I don't think I need anything else. The other thing I need to do is auto-wire the actual test. In fact, I can't auto-wire it because we are neglecting Spring for this phase. The service layer should not be too tied to Spring Framework. It would be nice if it's just plain. So here, what I'll need to do is I'll use a Mockito annotation called inject mocks, and this inject mocks will bring in the service itself. So movie service, and that will be our service. And we'll have a test function. So one of the things we'll want to do inside the test is to save a movie. So save movie. And this will handle saving a movie. And in the test, of course, we'll use the service, but I see we already have problems in our test. So let's run it first, just to be sure. and we see that it's broken. So now we have license again to go to production code. So I'll create a new class here, call it movie service. And movie service will be our actual service. So I can add the stereotype annotation for service just to make sure that it's discoverable by Spring. Although in the context of our test, it won't be too important. And I don't need to do anything else there. So once we have the service, we can go ahead and call service.save movie. And what service.save movie will do, it will, first of all, it will check if movie already exists. So if the movie already exists, what do we want to do? We can return a 400, telling the client that that movie already exists. If not, if it does not exist, we can save the movie and return 200, telling the client that the movie was created. In fact, we should use a 201 here. But instead of these status codes, because this is more of a controller's job, I'll try to communicate this to the controller. What is the best way to do it? So if it already exists and we don't want to handle controller level behavior, we might return some kind of status, figure it out. And of course, for us to save the movie, we'll need to get a movie resource from the controller. So remember, here we're working with, we are sandwiching the persistence layer and the controller. So the controller will give us a resource, and then we'll convert that resource into an entity and save it. So we'll need a movie resource instead of a regular movie here. So new movie resource. In fact, we'll call this create movie resource. So that will be the resource we'll be using. And this resource, unlike the movie resource, it only has the name of the movie and the release date. So it will be slightly different. So the name for the test we'll be using is Dark Knight, and the release date we'll be using is .of. I don't know when Dark Knight came out. I'll assume it's maybe 2010s, 2012 probably. Some month there and some date. So that will be our release. So this will have the name and it will have the release date. So then we can pass that to save movie, pass that movie resource. And yeah. So if this operation is successful, we can return a resource that has, although I don't want to store the status codes in the resource. So perhaps let's not worry about status codes at this stage. Instead, let's just see. Yeah, we can return something that might serve as an equivalent of a status code, which is like a resource thing, result. And this result can wrap multiple things. It can wrap the resource. It can also wrap the status code. And once we do that, we can perform some assertions on that result. So one thing I'm hoping the result will be able to do is wrap the, so once you create a movie resource, what are we returning to the client? Should we just return a plain status code? I'd prefer we return the created movie resource. We should have the ID of the movie, so that if the client wants to call back to retrieve the movie later, they have the ID that represents this movie. So created movie resource will be what we return back to the client. So movie resource. And this created movie resource will just have the typical properties, but it will also contain the name and it will contain the release date of the movie. Okay. This result will be a bit of a complex object in that I expect it to have this form. So it will be a result that wraps the created movie resource, but it should be generic so that we can use it for other things later on. So I'm seeing our stream is, we're already 1 hour 30 minutes in. So I'd like to pause it here, and then tomorrow we can proceed with the actual service layer, the whole implementation, and then we'll do the controller. So my time is a bit stretched. I started a bit later than I usually do. I just didn't want to skip today. So we'll resume with this tomorrow. We'll write the remaining bits of the service layer, and then we'll go ahead and handle the controller, which should be fun. Yeah. So thank you for anybody who joined the session. And if you have any questions, you can leave them on the chat, or you can reach me on Twitter at some programmers, and I'll be more than happy to answer those questions. So that's where we conclude the stream. So we've gotten the persistence layer done. So we'll just come back to design and implement the service layer, and then we'll do the most interesting bit, which is the REST endpoints on tomorrow's stream. So stay tuned for part 2 tomorrow. Bye bye.